Good morning, dear students, and welcome back to online classes. Last day, we started with the study of atoms and molecules in lesson 3. We discussed about the properties of atoms of various elements. Matter is anything that takes up space and has mass. All matter is made up of atoms. Atoms are the building blocks of matter, sort of how bricks are the building blocks of houses. In our last class, we discussed the properties of atoms with reference to various scientists, chemists spoke about. John Dalton, on the other hand, also described the properties of atoms on the basis of his experiments. He concluded his experiments with the laws of chemical combination, and he proposed a few characteristics or postulates about atoms. His work was concluded in Dalton's atomic theory. Today we will discuss the postulates of Dalton's atomic theory along with its limitation in detail. It was in early 1800 that John Dalton, an observer of weather and discoverer of color blindness, among other things, came up with his atomic theory. The idea of atoms had been proposed much earlier. The ancient Greek philosophers had talked about atoms, but Dalton's theory was different in that it had the weight of careful chemical measurements behind it. It wasn't just a philosophical statement that there are atoms because there must be atoms. As he described his atomic theory, he said that postulate 1, matter is composed of very tiny or microscopic particles called atoms. Atoms are the building blocks of matter, sort of how bricks are the building blocks of houses. Postulate 2, atom is an indivisible particle. Atoms of hydrogen, oxygen, nitrogen, etc. are not able to be independent existence, whereas atoms of helium, neon, etc. are capable of existing independently, though these atoms cannot be broken down to give the new atoms of any other element. We cannot find the breaking of hydrogen atom to give silver, breaking of platinum atom to give oxygen, and so on. Postulate 3. Atom can neither be created nor it is destroyed. Atoms are not created nor be destroyed in a chemical reaction. Atoms rearrange during a chemical change. Postulate 4. Atoms of an element are identical in size, shape, mass, and in other properties. These properties include physical and chemical properties. Like, for example, an atom of sodium, whether present freely or stored in kerosene, is a soft metal, highly reactive, with atomic number 11 and mass number 23. Postulate 5. Atoms of different elements are different in their properties. Like, for example, atoms of hydrogen and oxygen are not capable of independent existence, though two atoms exist as gases. The two elements are non-metals, reactive, highly compressible, but possesses different physical and chemical properties. As hydrogen is non-supporter of combustion, oxygen is a supporter of combustion. Both possesses different atomic number and mass number 2. The atomic number and mass number of hydrogen is 1, whereas of oxygen, the atomic number is 8 and mass number is 16. Atoms combine with each other in small whole numbers. Like for example, an atom of sodium combines with 2 atoms of chlorine to give an atom, basically a compound. The compound which contains an atom of sodium and atom of chlorine respectively. Atoms never combine in fractions or decimals during chemical reactions to form the compounds. Postulate 7. All chemical reactions are due to combination or separation of atoms. Like for example, hydrogen and oxygen atoms combine to give water. Carbon combines with oxygen atoms in presence of sufficient supply of oxygen to give carbon dioxide, heat, and light. The same carbon atom, when combines with insufficient supply of oxygen atoms, give carbon monoxide, less heat, and yellow colored light. Whereas calcium carbonate on heating gives calcium oxide and carbon dioxide. Various atoms are formed from one substance on its breakdown. Chemical reactions are here due to addition, decomposition, which can be also by displacement, etc. of atoms. As they are postulates of Dalton's atomic theory, it had some limitations or the drawbacks. These demerits include: number 1, with the discovery of subatomic particles, like for example, electrons, neutrons, and protons, the atom can no longer be considered indivisible, as well as smallest particle. The atoms of same element are not similar in all respect. They may vary in mass and density. This was the limitation to postulate 4. Such atoms of element which may have same physical chemical property but vary in mass and density are known as isotopes. Like for example, chlorine has 2 isotopes having mass numbers 35 and 37 respectively and atomic masses 35 AMU and 37 AMU respectively. Atoms of different elements are not different in all respects. Atoms of different elements that may have the same atomic mass and mass number are called isobar. This point is the contradiction to postulate 5. Like for example, argon and calcium are isobars. Argon is a noble gas, whereas calcium is a metal. Argon is represented by Ar, its symbol, and calcium Ca. The atomic number of the elements are 18 and 20 respectively and do differ in chemical properties. But these 2 atoms of elements have same mass number, that is 40, and atomic mass 40 U respectively. Third limitation, and the fourth one. Different elements combine in simple whole number ratio to form compounds, which is not seen in complex organic compounds like sugar. The formula of sugar is C12H22O11. If we see the ratio of atoms of carbon, hydrogen, and oxygen, it is as 12:22:11, which is neither smallest nor simple. The last, the theory fails to explain the existence of allotropes. The different physical forms of an element which do possess similar chemical properties are allotropes. Like for example, diamond and graphite are the allotropes of carbon. Both are chemically the same, do have similar chemical properties, but due to difference in the arrangement of atoms, the diamond and graphite look different. They possess different physical properties. Diamond is hard as well as non-conductor of electricity, whereas graphite is soft and good conductor of electricity. So we have discussed the postulates and the limitations of Dalton's atomic theory. The limitations of Dalton's atomic theory gave the opportunity of discovery of the atomic models later on, which we will study in lesson 4. So today we discuss the postulates of the theory, which are as follows. All the matter is made up of small particles called atoms. These are not only small but very small, cannot be seen with the naked eyes. Atoms are indivisible. Atoms can neither be created nor be destroyed. Atoms of a given element are identical in mass and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atom are constant in a given compound. We also discussed the drawbacks of the theory as Dalton said the atoms are indivisible, but we all know that atoms can further be divided into still smaller particles called electrons, protons, neutrons. He again said that atoms of an element have exactly same mass, but they can have slight difference. He also said that atoms of different elements have different mass, but some atoms of different elements have same mass too. These are known as isobars. Now, in our next class, we will study about laws of chemical combination, which gave the basis for the postulates of Dalton's atomic theory. Thank you.